Let me start. So, what is a BESS system? The BESS system are rechargeable batteries that can storage energy from different power resources, such as electricity from grid and also renewable power, like solar or wind, and you can discharge it when needed. So a typical BESS system will consist a battery system and also a BM system and a hardware like inverter to convert AC power to DC or convert DC power to AC. And also you have a EMS system, a software that can monitor and control the energy flow in the BESS system. The general applications for the BESS system right now you have like residential and also commercial and also like big scale projects for utility. So for HDL BESS system right now we are specialized and committed to residential part. Here, there is a data about the residential energy storage market. It is valued at about 9.34 billion in 2021 and expected to reach to 37.90 billion by 2028 with a rapid growth CAGR of more than 22%, according to the forecast. Nowadays, about the residential battery market, the highest is in Asia Pacific areas, and then medium one in Europe after that, and also American, and then Africa and the Middle East, some Middle East countries. Last year, there is a booming of new installation of the residential capacity, and the total capacity for new installation is about 13 gigawatts. Among the total installation capacity, the Europe market, they share more than 70 proportions. And the second market is for United States. And the others share about 90%. But according to the situation and reports for 2024, Pakistan markets and some other emerging countries like Vietnam and Southeast Asia countries, and also in Middle East, the residential BESS system, the growth is more higher. So what is the force that drive the growth of the market? So it has about 4 main factors. The first one is the carbon neutral target. Due to the climate situation, most countries, especially the developed countries, that they have issued and give carbon emission targets. For example, in Europe, they have promised to reduce 40% of the carbon emission in 2013, and also China government, they give permission also for 2017, 16 for the carbon neutral targets. And also the increasing energy price is another important reason to drive forward of the BESS market. This is generally caused by the inflations and also the lack of investment in grid facilities. And the other very important reason is decreasing PV and BESS product is cost. In 2023, the price of lithium battery was declined about 83% compared to 2013. And also the energy incentives that increased the interest of people to invest for residential BESS system. For example, in Germany, there are about 30% invest subsidy for BESS system from the government, and also in Italy, in last year, they have a tax credit for the investment of residential BESS system up to 110%. So what is the value of BESS system? So for the residential, for the homeowners, the BESS system, they can allow you to get energy independence and also more power reliability. If there is an outage, you can have backup power. And also in some countries, because the grid is not stable and the voltage can be fluctuation highly, and also the inverter, it can also output very stable current and voltage to protect your home appliances. At the same time, you can use the peak value pricing, make use of the peak value pricing arbitrage by using the batteries. You can store the battery energy from grid into battery in peak time, in valley time, and discharge it in peak time to get margins from the price difference, and also for commercial and industry. For utility sections, the main benefit is from the frequency regulations, and also like peak shavings, and also renewable energy integration, because nowadays a company with more and more renewable energy like solar or wind constructions or plants, sometimes some of them in daytime, because the consumption is not enough, so some of them will be waste. So the battery system can storage and you can use it in peak time. So by this way, they can improve the power grid efficiency. So here is about achieve energy autonomy with the solar panels. So if you installed enough capacity of solar panels, and there is possibilities to realize energy independence. And the other benefits for homeowners is the backup power. In case a power outage from grid, the BESS system can provide you uninterrupted power to your homes to keep your food still cold, to make the work of the fridge, and also to power the lights and keep the Wi-Fi and also security system working. So you have like a alternative for UPS. And also it can reduce your energy bill by peak shaving and time use of the BESS system. If you charge the batteries from grid in valley time and discharge it in peak time, so you can benefit from the price differences. Here is just an example. So why we choose HDL BESS system, the second generation? Here I will share you some outstanding features of HDL second generation BESS system. So first of all, from the system level, now you have pure solar energy brands like Huawei, like Sungrow or Solis. Those brands, they only have like BESS system, and also there are brands that concentrated only in smart home system, and also nowadays more and more brands like Silent and also Luxon, they already integrated with some inverters or BESS system. And HDL is targeted to provide one-stop solutions. So you have one brand with both systems and one application to control it. So with HDL total energy management solutions, you can have controls for the energy production and the energy storage, and also with the help of regulation of smart home system, you can also do more things in energy consumption. And besides, you can use, like for example, use smart home system to switch to economy mode to decrease the energy consumption, real-time energy consumption, to enhance, to prolong the use time of your battery system. And also, with HDL applications, which can control both smart home system and also BESS system, you can also realize automation or interworking with between the BESS system and the smart home system. Here, you can easily doing automation by, for example, if there is, you can set like automation in your application. If there is a grid outage, you can switch off specific channels For example, the air conditioning, or you can also increase like the temperature of your floor heating, your AC system, or you can switch your smart home system to economy mode. So with the two systems seamlessly communication together, you can play inside to realize automation and convenience. Besides the system interaction, from the product level, for the HDL second generation inverter, we adopt high voltage technology. It can get higher efficiency because the energy conversion topology in between the battery and also the inverters. So it can achieve up to 99% during the DC to DC conversion. It means that when you charge the battery and also discharge the battery for one circle, you will have a higher efficiency than like the low voltage battery system. So if you in your BESS system you have like more batteries, you will get more power saved. And also for HDL high voltage inverters, because its voltage is up to like 500 DC input, so its current will be smaller than the low voltage hybrid inverters. So its heat radiation is also much smaller, and the structure of the electrical scheme will be more simple. So it is more stable and cost effective compared to low voltage technology. And also for HDL inverters, it's already built in DC arc protection, which is only used in high-end inverters. So with this DC arc protection, we can reinforce the safety for operation and the maintenance of the solar system. And also we adopt the casting housing. It is more robust and sleek design. There is no edges in the housing, and we use natural cooling instead of fans, so it is more quiet, and the lifetime of fans is limited, and sometimes it will absorb dust to cause problems for the system. The last one, HDL inverter, is only 16 kg. It is very compact design and easier for carrying and installation at the same time, can save the logistic costs for long distance transportation. And besides the inverter, for the HDL Power Guardian, these unique devices, it will enable you have more controls for the loads and also the power, the total power system. First of all, it is flexibility for whole house backup. For most of the inverters in the market, it just have one backup port, and it supports like only one channel backup. And when you install the system, you should decide and preset the backup loads and the room backup loads. You need to divide the backup loads and also normal loads, means room backup loads. If your battery is not enough, or you don't want to invest a much higher budget, and once you install the system, you cannot change it. But with HDL Power Guardian, you have choice to control the whole house. I mean, for whole house backup. How it's realized, I will introduce later. And with the Power Guardian, you can automatically switch off overload loads. So there will be no interruption for your system to work. For example, when someone in your home switch on a very high load like air conditioning, if at that time the battery has not enough power inside, the inverter will start protection and stop working for the normal inverters with backup function. But HDL Power Guardian, it has some built-in smart relay module inside. It has current detection. It can detect the energy, I mean the load of each connected loads, the power, and if there is insufficient energy at that time, it can automatically switch off the overloaded loads. For example, like the air conditioning, or maybe like washer. So you have no interruption for the power to improve the user's experience. At the same time, we have smart load control with the relay modules inside, and also the software functionalities. You can set like priorities to different channels of the loads, and also the generator supported by the Power Guardian. So this is a very critical features for some countries that they have very unstable grid or lack of grid facilities. Now, I would like to introduce you the current HDL second best system product families. So right now, we have for the inverters, we have 3.6 kilowatt and 4.6 kilowatt and 5 kilowatt. This is for single phase hybrid inverters. Those products are ready. And for the 3-phase inverter, it is under development, and we are going to launch to the market in the first quarter of 2025. And for the ESS system, for the energy storage system, we have the BMS control module This one can support both single phase and also three phase. And for the battery units, right now we just have one module which with the capacity 5.12 kilowatt hour, and those two devices also are ready. And also the Power Guardian, it is under development also. And there is another device, we call it diverter. This one is a hot water diverter, which used to make use of the surplus solar powers that you can lead it to heat the water, so that you can keep the excessive energy into the water instead of invest more batteries. So this device is commonly used in high latitude areas like in Europe with cold weather. And also the EV charger is in plan. We have not yet started it. And the application, it is also ready for test. We have, for the application, right now we have two different combinations. So first of all, for the standalone solar system, you can use HDL Zentra solar application. And this Zentra is the new brand that we will use specialized for the BESS system. And this Zentra solar application, it has installer account and also end user account. So you can use it for both configuration and also for end users. At the same time, if you use HDL Home, because right now the new HDL Home application, it is able to control the BESS system, but it is only for users. The configuration of the solar system, you still need to use Zentra application. So with this combination, you can also control the system fully. And with HDL Home, you have extra benefits because you can control both systems in one application, and you can also DIY the automations. So right now I will introduce the hardware. The first one for the single phase hybrid inverter, it's the basic parameters. First, it has two MPPT inputs, and for each solar array, you can support maximum 500 volt DC voltage input, and also the maximum current is 13 ampere, and the MPPT voltage range is also wide. And this hybrid inverter, it can support both DC and AC coupler. It means that if you have existed, for example, in some houses they have an existing solar inverter. In old times, they don't support energy storage system. So with our inverter, you can also connect inputs the AC from the existed inverter. and then to add the BESS function. And the maximum efficiency is up to 97.40%. It is also high. And we have said that it adopts natural cooling. There is no fans, so the operation noise is very low. It is very quiet. And the temperature support is also wild and can adapt the hot weather in the tropic areas and also very hot countries. And it can support the altitude up to 4,000 meters above the sea. So you can install it in mountain areas. And it is also IP65. You can install it outdoors. Here there are more details parameters, so you can review it if while the data sheet later I will share. So here we just have a quick skip. Okay. And now for the energy storage unit, it includes the BMS module and also the battery unit. For the battery unit, its rated power is 5.12 kilowatt hour, and the rated capacity is 20 ampere hour, and it is LFP lithium batteries. And also the battery is high voltage. For each one, its nominal voltage is 256. The charge rate is 0.5 C, and the discharge speed power is higher, is 1 C. And the circular life span is high. It is up to 6,000. When you operate it, working under 90% discharge depth. For the BMS module, it can self-adaptation to support one-phase or three-phase inverters less than 15 kilowatt. And the BMS can support maximum one BMS module can support maximum 3 battery units. If more than 3 battery units you want to install to work with the inverter, you need to parallel more BMS, and the maximum right now support is 3 BMS module. So the largest BESS capacity right now is 45 kilowatt hour. Here are more details. In this part, I will introduce about the application scenarios and the system, the diagram of this application. In the last part, we just introduced single devices. So how the products that you combine together to meet different the requirements from different countries, from different situations. So you will find answers from this part. And first of all, I would like to introduce to you about the working mode of the BESS system. Generally, it has two right now. First one is the self-consumption mode for the BESS system. What is the self-consumption? So first of all, it will provide the solar power. The inverter will provide the solar power to feed the home loads as in priority. And if you still have surplus power, it will start to charge the battery. After that, if you still have surplus power, it will will export the energy to the grid. So this is the working logic of self-consumption mode. So for example, if the system working in on-grid situation mode, if the battery is full, so all loads were supported by the solar panels, and the excessive energy will be directly exported to the grid because it is a grid-tiled system. And if the battery is not charged, is not fully charged, like 90% or 100%, the surplus power energy will use to charge the batteries. And if the power from PV less than the loads, so if in this case, if the battery is not full capacity, all the loads will be supported by the PV and the batteries and the battery. And if the battery SOC is between 20% and and less than 50%, means that it also have not used out. It will used in priority to support the loads. After use out, it will compensate it from the grid. And in off-grid system, if the PV energy is more than the consumption of the loads, all the loads will be supported by the solar panels if battery is fully charged. And if battery is not fully charged, and it will charge the battery. And if PV energy is less than the loads, so first, if battery energy is full, all the loads were supported by the PV and the batteries together until the battery use out. The inverter will shut down because it is grid off. It cannot take power from the grid. The other working mode is the peak shaving. In some countries, some people also, in some cases, we also call it time of use. And the peak shaving, it works like this. It charges batteries on valley time and the discharge on peak time. And the peak time and the valley time period you can set preset inside your application. Later I will show you. So generally for the solar plants, that from the physical connection aspect, you have a grid-tied solar plant and you have a grid-off solar plant. So here we will divide into two categories. The first one is for the grid-tied solutions, because the inverters is hybrid inverter. It can support both off-grid and on-grid. So the first solution is for the grid-tied to cell power. It is applicable for the countries or the areas with very stable grid, and also you export the power to the grid is allowed. So in this situation, you can choose the product combination is solar panel plus inverter, and the application you don't need a battery, because there is no backup power demands here. So the working mode here you can choose is self-consumption. So first of all, the loads will be supported by the solar panels, and the surplus energy will be sold to the grid. So it is a simple diagram. So here is the diagram. In the grid-tied solution, you must connect the current transformer to detect the energy direction. For example, it needs to know the power is from the inverter cell to the grid. The second solution for the grid-tied solution is the maximum self-consumption grid-tied solution. So here, the application situation is, first you also have like stable grid, and the feed-in grid is also allowed it. But in this, why you need to want to realize maximum self-consumption, because if the selling price of the electricity from your solar system is much lower than you take the electricity from grid. So you have to consume maximum surplus powers by your system, by your loads. So here you have we recommend a device list combination, solar panels and the inverters, and also the diverter. The diverter, it can maximally make use of your surplus power to store into the water. And the water is okay. So the working logic is like this. First of all, the solar panel will fit home loads in priority. If there is surplus power, it will start hot water diverter to heat the water tank. And if there is still surplus power, it will sell in to the grid. And here you need to pay attention like that. Normally we recommend why your solar production is more than is the power production from your solar panels is more than 3 kilowatt-hour than the home load consumption. This solution is recommended because the diverter is current. The rated current is about 17 and 13. So its rated power is up to like 3 kilowatt. In this case, you can use the hot water diverter to replace the battery function. And for the grid-tied plant system, the string capacity can be maximum about 1.2 times more than the rated power of inverter. And this is the diagram for maximum self-consumption grid-tied solutions. So here you can see the diverter. It can help to store the surplus energy into the water, the hot water. The third solution for grid-tied plant is with zero export. Why you need to do zero export? Because in some countries that they have stable grid and fit-in grid is allowed, and also the peak valley price difference is high. In this case, with zero export, sorry, I made a mistake. In this case, that in some countries, because the grid facilities, they cannot undertake too much energy, renewable energy that you fit into the grid, they will charge you. So you need to activate the zero export function here. So in this application, appliances, the device combination is like you need solar panels and also inverters, the basic, and also you need the battery system to storage the surplus energy, because it is you have no profits to sell the power to the grid, so you need to use it or you need to store it. So the working model is like in daytime, the solar panel to fit the loads and the surplus power stored in the battery is same like self consumption, and in nighttime you use the battery energy in priority, and the insufficient one you take from the grid. And in peak pricing period, the solar power will fit the home loads in priority, and if the power from PV is insufficient, it will be compensated from the battery. So it is like the self-consumption, the same, and the invalid time because you need to take power from a grid to store into battery. So this is like time of use working mode. And in these solutions, the solar panel is not always necessary. And if you choose to add the energy storage system, at least you need to use 2 batteries. This is a diagram for this grid-tied with stereo export. Besides the grid-tiled solutions, the HDL BESS system also supports off-grid appliances. So why we need the off-grid appliances? Because in some countries, in some like the lack of grid facilities, such as in farming areas, which is far from the city, or in rural areas, or in some offshore islands, or in some undeveloped countries that they have no grid, not enough grid. So this purely off-grid system is very simple. You have the solar panel, you have the inverter, and the energy storage, the batteries. So the working mode is like in daytime, you use solar power to feed your home loads, and the surplus power stored into battery. And in nighttime, you can only rely on the battery to feed your home loads. So this one is quite simple. The second solutions for the off-grid, we call it whole house backup power solution, because especially in the areas with unstable grid, it will, for example, it will have like frequently outage. In case there is outage, you have no power inside the house, so you need a backup power solution. Here with the device combination we recommend is solar panel, inverters, and the battery, plus power guardian. Here the power guardian is function like a backup power gateway. So its working mode is like, first, if the grid is normal, the solar power will feed the home loads in priority, and the surplus power stored in batteries. And in case there is a grid outage, the power guardian will automatically switch off the connection with the grid and then start the battery system to power home loads. And when the home loads power is more than the inverter output power, means at that time if the solar power is insufficient, it will automatically switch off the non-essential loads to secure the power supply. to essential loads. And in case it's a detection, the grid recovery, it can also automatically tell the grid. And the users is able to preset the logics to switch off a specific load. In case the outage happened and the system switched to the backup power working, by this it can extend the usage time of the battery extremely. So the trigger conditions can be like the real-time power consumption of your home loads, or the SOC, means the remaining the capacity level of your battery. Here is the diagram. So you have an extra device, the power getting. And the third solution is whole house backup power with generator. In this applications, you have a generator added, especially for big houses or big villas. If you because the battery the cost is higher, so maybe you don't invest as much as battery unit, so you will have like a generator as an alternative solution. So in this case, we can provide this combination. And the difference with the last backup, whole house backup solution is that with the generator added, if the battery use out, the system can automatically switch on the generator. And also for these solutions, you have some notice here. First one, the system can automatically switch on off the generator, so it can give you like 24-hour uninterrupted power supply for your house, even your battery is limited capacity. And also the generator can charge the batteries. Yeah, because the generator if its power is high, more than the home loads, in this case, the generator will charge the surplus power into the battery. And if the system detects the SOC of battery, by this way, it can reduce the noise and the pollution. Yeah, because when the SOC level is reached, it will automatically switch off the generator. And the users also can set automation logic of switch on off the generator. And also the smart load control can be realized by the Power Guardian. Here is the diagram for this solution. So for the first part of introduction of the HDL second generation, BESS system is finished. So for the second part, installation and the electrical connection, First one for the inverter. When you receive the product, you have already a package of accessories for the installation parts. Here is the list. It is mainly about the components and also the tools to help you, and the connectors or terminals to help you to do the installation, and also connections between the product and the system. Here I will not introduce one by one, but you can review to this because it is like a commission job. We already made videos to explain how to install it step by step, and also there is installation manuals. So in this so today I will not introduce too much about it. Just some important notes. So this one is the simple workflow steps for installation of the inverters. Yeah, because it is wall mounted, and so first one you can use the label, use the positioning paper to labeling the position to drill the hole, and then you cut holes, you put the plastic inspection tubes, and this one is no need if it is a wooden wall, and then you install the bracket for the inverter. After that, you hinge the inverter onto the bracket, and then you fix on the bottom of the inverter to fix the inverter onto the bracket to let it steady. So it's very simple, just 6 steps you can finish the installation. And now it's about the appearance, and also we will show you the connectors and the connection ports about the inverter. So here you need to pay attention, like the PV DC switch, which is used to input the solar panels. It is used to switch on off the power from solar panels before you power on the inverter. And you have PV input ports, and also there are 2, because this inverter supports 2 solar hours. It has 2 MPPT ports, and you have battery connectors, and also the battery needs to communication with the inverter to be command for charge and discharge. And also here the inverter has Ethernet communication port to link with the cloud for communication. And also we reserved a parallel port here, which is also RJ45 port, which will be used for in the future for capacity expansion purpose. For example, you can parallel like 2 or 3 or maybe more inverters together to support big loads. And here we have AC port here, and also the this communication port for 14. Later we will give more details. This one is generally to it has 16 pin is a 60-pin connector. Here is used to integrate with third-party hardware or software system or gateways, and also it's like the CT also connected with this port, and also we have 4G or Wi-Fi ports. In the future, we will also have our dongle for data communication with the cloud via Wi-Fi. And also it has the ground point for safety purpose. So here is about the connections with solar panels and also the energy storage batteries and BMS. The battery itself will not directly connect with the inverter, but only the BMS control module. And here we have very detailed specifications, about this communication port with 16 pins. So here you can see here for 1 and 2, 3, it has Modbus power meter. In some cases, if the CT, because the CT is a simple current transformer, in some cases you need a more higher accurate power meter. So you can use this one to connect a Modbus power meter instead of a CT. And we already did integration with a specific brand chant. So you will also see the model number in the manuals. If you want to buy a Modbus power meter which compatible with HDL inverter. And here you can see that it has output for 12 voltage power supply and also for dry contact input. And here is about the cautions. It is for safety installation. Here for the PV switch of the inverter, you must switch to off state when you during your installation or connection of the inverter. And it is also not allowed to use the neutral line instead of PE wire to connect with the inverter. And also when you make cables or harness making, you need to make sure the cables are fully inserted into the connectors, because you see the product is very compact design, and the connectors here and is very small. So you need to do this job very carefully to make it work properly. So here is about the cable harness making. In the package, we already included the cable that's to connect between the inverters and the BMS module. But for the cable connect solar panels with the inverter, you need to buy it from the market. And so for this AC cable harness making, we have videos that I can share with you when you started the installation. So it is much better to see the videos. So here just we go through quickly. Now for the indicators of the inverter, it will, because we need to know exactly, I mean, generally about the operation status of the inverters. So first one, here we have three lead indicators. The first one is for operation, and the second one is for alert, for maintenance, and the third one is to show the grid tiled status. So here I will not introduce one by one. So for the alert one, if it is steady red, it means device is failure. So you need to check or you need to report to the factory. And if it is just off, means that it is working normal. And we also need to pay attention to the grid indicators. So first, if it is steady green, means the grid normal. So there is power from the grid. And if it is steady yellow, means that there is outage from the grid. And this is for grid tiled work mode. And if the inverter not on grid or connect with the grid, it is off grid working status. So it will be always off because it's switch off, it's disconnected with the grid. And if all of the lights are flashing the same time, it means that you are doing the starting or initiation, and also when you position the device, it will also quick flashing. We will also show you about it later. Okay, because the inverter is high voltage, yeah, from the battery and also from the solar panels. So we need to follow up the high voltage operation regulations to secure safety. So here we have some notice. I will choose some to emphasize it. The first one is the solar panel input current maximum is 4.3 ampere, and nowadays most of the solar panels, for example, the solar capacity, the rated power like 600 or 585 like this, is normal voltage is less than this, and the solar panels just series connection, so you have no problem. And the maximum PV string voltage is 550 voltage. In this case, you need to pay attention to the quantity of the solar panels you connected to one MPPT port, because like the standard, most common solar panels is voltage is like among 40 voltage, 40 DC, and in this case we can maximum connect like 13 pieces for each MPPT, and this is enough because the inverter is rated power is like 5,000 kilowatt. And also you need to pay attention about the positive and the negative terminal of the PV port, PV input port, because it have minus and the plus. So should plug in the right cables. Okay, so we just quickly go to the next page. Okay, this page is about the CT here. When you set the inverter work mode to be self-consumption, it is a must to connect a CT. Otherwise, the inverter will report alert. So, and also you can use compatible or the Modbus power meter as alternative. And also, if you already put the power guardian as part of the BESS system, you no need to connect an extra CT to the inverter, because the power guardian it already has this function to detect the energy flow. And you also need to avoid direct sunlight for your installation, because the direct sunlight will rapidly heat up the devices for partition areas, and it may trigger overheat protection of the inverter. And in this case, the inverter itself will decrease the output power and will affect your, maybe it will need to cut off some of your loads, overload it. And this one we already talked about. The inverter right now doesn't build in backup ports. So for backup power function should be only available with the use of power guardian. Now for the energy storage system, the installation is just some differences. Okay. The installations process is simple. Just here we have different brackets. Here, because we also need to fix the BMS module and also the battery onto the wall. So this wall bracket, it need to fix onto the top of BMS module and also the battery, as well as the wall, both. So in the fifth and the sixth step, you will see it. And compared to the low voltage one, yeah, we don't we use a stackable design, so there is no wire between the batteries themselves, so it's easy, and you have a quick installation.
Richard, sorry, I have a question.
Okay.
Regarding this base, we have received this base, and this base is not compatible with battery. We cannot install it. I don't know. Maybe it's selling few models of this base or something else, but we cannot install it.
You mean the second generation one, the product you received, right? Or for the first generation? Sorry.
No, second generation. Also in the set was included this battery base, but
yes.
These holes are not compatible with battery. I don't know why.
Okay, so you cannot stack the battery, the bottom onto the base, the socket has a problem. You cannot plug in, right?
Yes, yes. It seems that this base from other set or other model, I don't know.
Yeah, we just have one. I think after the training, you can share me the pictures. We will check, and if it's like what's the problem? If it is something wrong, we will send a new one. But I'm not sure how this come because we only have one base right now.
Okay, thank you. Arrange it. I will share my photos. Thank you.
Okay. And this is the connection for ports for the energy storage devices. So here you have a battery DC input port, and also output port. And the input port used to connect another BMS control module if you want to expand your battery capacity. And the output port used to connect with the inverter. And you also have communication with the inverter. And besides here, there are two protective earth ports here for double layer protection. And you have battery DC switches here to control the power from battery. And the lead indicators, the operation one is the same, and also for the alert one the same. Just for the battery indicators, if it is steady green, it means it is, for example, one green light stands for 25% SOC. Here, this just to show you intuition about the capacity level of the battery. And if it's blink green slowly, means it is under charging status. And if the battery indicator blink red slowly, means that is SOC is capacity level less than 10%. And in this case, you need to pay attention because if the SOC less than 10%, it may affect the cycle time of the battery is better more than 10%. And we already built in a mechanism. I mean, the software it will charge by themselves. I mean, even in like in self-consumption working mode, if the battery is less than 10%, by mistake, the system will automatically charge it. So to protect the battery lifetime. Okay, for the attentions, most of them is the same. It's about like safety, and try to use the same. And also for the battery, because you can stack like 2 or 3 maximum 3 batteries. So maybe so we have some attentions with like old and new batteries when you want to mix them together, or in some cases you want to expand the capacity and buy more one more battery to stack in. So here, so first you try to use the same batch of battery to stack together. Means like that it's better to, because the battery consistence for same batch is nearly the same. So it will if it is differences is too large, it may affect the lifespan of the battery. And when you stack the old and the new batteries mixed together, you need to make sure that when you start to stack it, the capacity level of those batteries is nearly the same. Because the inverter try to charge it, they will charge it averagely. If the balance is too big, it will take a very long time. And also you need to avoid direct sunlight against the battery, because it will keep rising the temperature up for this specific area of the battery. So it will have partial temperature differences, and this will affect the consistency or uniformity of the battery, and affect its lifespan. And right now, multiple BMS connected in parallel, not supported now, and will available soon. Okay.
Really,
Okay.
stop you. Can I ask you one question?
Yes.
As we know, for lithium batteries, we can increase the useful lifetime of them. For example, in our mobile phone, we can set the maximum charge, for example, 50%, or don't let it to decrease less than 10% to increase the battery life. Do we have this option in the inverters to don't come below 20%, or don't go up to more than 80% or 90% or not?
Yes. Later I will show you the application.
To increase the useful battery life.
Yeah. Yes, this is a basic function. Yeah, we can do it in the application. You can set. I will show you later in the configuration part. Okay, so when you complete the installation and also connection, before you power on the inverter and the BMS module and the battery, you need to make sure that, especially about the safety factors, you need to make sure it is in proper, follow the proper regulations. So for the inverter, you need to before the power on, you may need to check this checklist. The first one is for installation. You need to the vertical angle shall be less than 50 because the inverter you mount it on the wall, but if you don't fix it properly, and it has some movement, so this will also affect the function and the use of the inverter itself. And also, screw fixed, no shaking. This is basic. And also keep it away from the construction residues. And especially for the connection. So you need to make sure the wiring harness is connected correctly and also tightly. You need to check it. And also the ground point, the wiring is connected correctly. And you also need to put waterproof covers onto some terminals or connectors that you didn't connect with cable, because there are some reserved ports in the inverter. For example, the parallel ports. Right now, you it is not available. And for the CT connection, the cable cannot put in same conduct with other high voltage connection cables, because this will interference the CT, the detection accurate the data. So you need to put in separate pipe. And the PV switch in the inverter, and also like the breakers before input between the solar panels and the inverters should be switched off, must be switched off. And for energy storage system is nearly the same. And also you need to, especially for the battery, because it is chemical inside, you need to keep it away from inflaming materials. So this one is very important. And for the DC switches, yeah, it is the same. You need to make sure, secure it is disconnected, switch off. Okay, here is about the power on and the power off process, the right process. So first, if you want to, start to power on the system, the inverter, so first you need to switch on the DC switch on the BMS module, but not the inverter, and then switch on the breakers or other switches connected with the battery system. After that, the PV switch of the inverter switch on, and then you can switch on the breakers connected between the inverter and the solar panels. For the power off process, it is reverse. So first you need to switch off the switches connected with the inverter, and then PV switch of inverter to be off. After that, you switch off the switches connected with the battery storage. And the last one is switch off the DC switch on the BMS module.
Okay.
So this is just simple instruction. So the installation part is very quick and also simple. Before we started the configuration of the solar plant, we need to be first, of course, you need to have an account, right? And also you need to after you install the BESS system, and the first condition is that you need to make sure the BESS system and your mobile phone connected in same line. So this is the precondition. And also your mobile phone able to have Ethernet. So you need to access to the cloud account. So here I will show you the process. Now, first when you, okay, I need to introduce about the account system. So first one, because you need to have an account, and then you can operate or you can control the BESS system from application. For the HDL, for the Dentera solar application, you have two different type of accounts. the installer account and the end user account. And they have different authorities. For installer account, first one, during your configuration, I mean, before you hand over the solar plant to the users, you are able to create plants and add device. You can also delete plants and delete devices. You got full authority to configure the solar plant. You can edit the plant information, and you can set the parameters of the working mode of the plant. And you can also, of course, you can review the real-time status of the plant, and also the devices status like inverters, and also the BMS module that connects with this inverter. But after you configure it, sorry, okay. After you configuration and you hand over the solar plant to the end user, you can only review the plant. You can no longer to configure again. You need to get authority from the end user, and then the configuration will be recovered. It is the same like on-floor software. For the end users, they cannot, because it is high voltage system, so it is not allowed for the end users to create the plant, and also add devices is also not allowed, but they can delete the plant and also delete the device. And also they are able to authorize the installer after you hand over the project to them for maintenance purpose. So the review is the same. So this is the authority description about the installer and the end user account. Okay. After you register the account, how to register account? Okay, here. In the home page, when you download the application, you need, if you are an installer, yeah, here in the first page, you have like language selection, and here you have options to log in the account, different type, like installer or end user. And for end users, they can directly register the account here. But for the installer, it is the same as HDL IoT platform. You need to apply the account from HDL sales team and get approval, and then you can your account will be activated. But if you already have an account for HDL smart home system, you can also use it here. So is it clear for the account? Okay, I will show directly here. Let me scan again. Okay, connected. Okay. So I started my application. Here you can see the home page, and you have plans. But because right now I didn't connect to any, and here you have messages. The messages is like the alarm messages to note the end users or the installers, the working status or the failures of the BESS system. It is the push message will be showed here. And in the home page, actually, it's if you are an installer account, it will show like all plans you already installed and bind to your account. And also it will show which one is has failure, is fault one, and also the one offline, and also the solar plant is right now under construction or under installation, not fully completed or delivered. So here we will start to create a solar plant. So we click the minus symbol, and here we will enter into a page for plant addition. So here you have a name. Okay, let us taste one. So you can choose the time zone here. Ours here is this one. And the location of your solar plant, actually it will connect with cloud to automatically positioning with the GPS, but sometimes it cannot fully support. So you need to choose manually from here. So here we choose the location. This location here just the first line to show the country and the state and the city. And here is like the more details address. Okay, I type in the address of our factory. Okay, done. And you need to define, to choose the solar plant type. If it is here, you have two options: grid tied or off grid. So this inverter is a grid. This solar plant we installed already connected with grid, so it is a grid tiled one. We selected it, and you can also input the capacity of your solar, the string, your solar panel connected with the inverter. Okay, here 5. And this one is for currency. Yeah, we can choose Chinese RMB. And then here for the electricity price, 1.0. We put 1. Here is about, you can type in the budget of your solar plant. So we put 6,000 here. Then next step, In this step, because the inverter right now is already in the same lane with my mobile phone, so it will automatically appear in your research list. You see here, you can tick it, select it. If there are more, it will be shown as a list here. So here we just have one inverter. So we select it, add the device, and the next step, we need to edit and set the parameters of the inverter here. So device name, okay, test 1, okay, the same. Yeah, this device locates, for example, is used to locate the hardware. For example, if you installed more than one inverters there, you want to find which one you are connected, you are configuring. So you put this one, it will broadcast to the inverter, and all the lead light indicators in this inverter will flashing, so you know which one you are configured. And for the time here, when you the time here is very important, because the inverter, they need to synchronize the data with the cloud. So it is you need to make sure that the time is have no big difference with the real time. The time rule, okay, is read from the last step. And here the grid mode. Why there is a grid mode here? Because this plant, solar plant that it is a grid tiled one, and for the grid tiled solar plant in many countries, you need to do certification. For example, if we use the solar plant in Italy, they have their standard, they have their special technical requirements. So in the future, if we completed the grid tiled certification with Italy or with other countries, it will be shown in this list, and then you can choose from it. So this is also very important. If your country has such kind of standards or requirements, we must first to do the certification, and then you can tile the plant to the grid. And the working mode here, we choose self-consumption. And the next parameter you can see here, charge cutoff, SOC. This is the question that Hamid already asked, that in order to protect the lifespan of the battery, so you need to set the maximum charge capacity of the battery. So here we recommend you to use 90%, and also discharge the lowest discharge level of the battery. Better to set like 20%. Of course, you can set to 10%. And also for the charging cutoff SOC, the limitation, you can also choose 100, but it's better to choose like 90%, not fully charged. And this one for battery peak shaving power. This parameter is related to, for example, when you set, actually there is a small mistake here, because this parameter only you need to set it when your working mode is peak shaving here. You see, when we choose peak shaving, then you can set like you can have 2 time periods of charge time, because if you, in case you choose peak shaving, means that you want to charge your battery in peak time, discharge it in peak time and charge it in volley price time. And here you have 2 time periods to set. Like we can set like for charging time in 2 o'clock. Zero o'clock for one, and the other one for 4 o'clock. And for discharge time, so in peak time, so we can choose like in the morning, 10 o'clock. Select this time. Okay. It's not available now. Peak shaving. There is problem now, so we will skip. Just set time invalid. 这是怎么回事？
放电的时间段必须要设，你不能只设一个。
哦，放电。
有一个充电，要有一个放电。
Okay. Here, if you set the charge time, you must set the discharge time. 这个不对吗？
对。
Okay.
这里也再设一个，不能跟上面冲突。
Okay, cannot be the same, but I think there is a small issue here. Okay, 10 o'clock 是早上10点。
你这是10分钟，左边那个字
哦，end time. Okay, 10 o'clock. Oh, this is a time period. Yes, I made a mistake. Okay. Cancel. Because here I think is the problem. Yes. So 2 should be like 2. Okay. Okay. Like we from 4 o'clock to 6.
接受4点，就在4点之后。对，可以。
Okay.
然后再设下面。
Okay. So.
可以在9点。
Yes.
有18点吗
？16点。Okay. So should be different, but this one is 20. Okay, discharge time. Okay, done. And for the battery peak shaving charge power, here means that you can set the highest threshold of the for the inverter to charge the battery from grid, and the maximum grid feed-in power. It means that the maximum power that you export to the grid. This will be useful in some area, in some projects. For example, you don't want to, if the price is very high from the grid, you don't want to take the power from too much power from the grid. So you can set here the highest threshold, like 2000 and 10. And the export, actually the export, the value range can be from 0 to 5,000. Okay, maximum. Okay.
BMS.
And the BMS, yeah, because the BMS connected to the inverter, we named it BMS. Okay, this one for locate.
对，因为太慢了。
哦，时间太长了，那我要重新设一下吗？
你可以快，哎，怎么？
Okay, successful, and then it will automatically switch to the page of the plant status. From here, you can see the real-time status of the solar plant. So here we have data here. First it will it show that the work mode is peak shaving. Okay. And now the yield today means the power production today for the solar plant, because we just created it. So it is 0, and the earnings also the same, is 0. And this one for this month, this year, and totally yield. I think this is because the history totally yield means the plant when you created it, because we have a history data here, so it show 2.1. And in this part, for the energy flow, real-time energy flow, we can see that right now the PV power production is 0 because it's nighttime here. So it is already after sunset, so there is no power produced. So all of the power we take from the grid, and the load consumption right now is 2.46. Okay, here this part is about the power balance, the production and the consumption comparison here, and also like the environment benefits for the history. So you can review for each day. You can choose the time. Yeah, because it's just started today. And you have months, year, and also life cycle time. And the first one is about the power production. Is about the distribution of the power consumption. So here we have no data. You see, to the load and to the grid and to the battery means the power produced and the consumption by proportions of the loads and the grid or the battery. And this one is about the electricity consumption, the resources proportion from solar panels, how many kilowatt hour, and from battery, and also the electricity consumption from grid. So you have other different type of data comparison and statistics. So this one for hour, and okay, 这是9点了。
这个是你刚刚的用电功率吗？
对，
因为已经到晚上了 ，PV 不工作了，所以这个用电功率没有。
Yeah, because you can see here, we just have consumption data. Yeah, because now there is no power production in the solar panel. And in the device list, you can find the inverter that it's tied to this plant. And you can see the status of the solar panel, the string status here, the voltage, and also the AC output. This is the status related to the PV inverter. And also the temperature of the inverter inside is a healthy information. And also during, for example, if you already created the solar plant, you want to add another inverter into this existed solar plant. So you can do it from here. Device status. Okay, we skip to the plant. Okay. Okay. And from here, we can add another inverter. No device found. Yeah. If the device already bound to one solar plant, you cannot edit it. So here it will display the notification. So I just show you how to add an extra inverter. And also here you can, from the page of the plant, you can delete the device. And also you can also edit the plant information. So this one, okay. And the last step is after you completing the configuration of the solar plant, you need to deliver to the end users. So here you have 3 ways to hand over the solar plant. First one is that here you have a unique QR code for this solar plant. The end user can use their application to scan this QR code to add this to take over this solar plant. And at the same time, you can use QR code here from your application if you are face-to-face and to scan their account QR code. So by this way, you can deliver you can hand over the solar plant to the end user if you are sit face-to-face. And there is another solution is that you can type manually their account name. So there are 2 ways for remote solar plant handover, and also there is a way for face-to-face handover. So we can try. 你的有吗？是139。Okay. We have another end user account. 88。7710。So we already deliver this one. So now. 你这边再刷新这样就没有权限了。Okay. 我觉得我这边授权。现在可以看吗？现在权限就变了，右上角就没有那些东西。You see here, we have no access to the plant edit. We cannot add device now because the solar plant already hand over to the end user.
现在我这边放个权限，你那边空的就多一些。你再看，你那边现在可以设置。
Okay, so again, if there is a demand need to maintenance, so we will ask the end user to authorize.
退出刷新一下，
Okay, we
重新进行。
again enter. Now we got again the rights to add device
你又可以继续给它提。
for okay, no device fund. Okay. So this is the full process of solar plant creation and configuration. So that's the end of today's training.